All right, we're looking at section 4.9, which is on antiderivatives. So let's look at the definition. It says the function capital F of x is an antiderivative of lowercase f if the derivative of f capital F is equal to lowercase f. That's kind of a mouthful, but basically what it means is, normally if we take the function f of x, if we take its derivative, that's actually worth writing. If we have the function f of x, and then we have the function f prime of x. Going this direction, we're taking the derivative. And going this direction, we're taking the antiderivative. So let's look at this example here. One thing about the notation, though, if we start with some function and we find its derivative, we use the prime. If we just start out with some function and we want to take its antiderivative, well, what we typically do is use the uppercase letter for that function, for its antiderivative. So let's look at this example. It says find some antiderivatives of the function f of x equals 2x. So what this is asking us to do is find some functions that this is the derivative of. And the first one that you might think of is, this is the derivative of x squared. That's one potential answer. Because if you take the derivative of x squared, you get 2x. It's not the only answer, though. Another answer would be f of x is x squared plus 5. Why 5? Well, no particular reason. It's a constant. So if we take the derivative of this function, we'd get 2x plus 0, which is still just 2x. So really, what we could do is write this in general. We could say f of x is equal to x squared plus capital C. If I write it like this, the capital C is any constant and this thing is called the general antiderivative. Of f of x. General because this categorizes all of them. Let's look at some examples here. What we're going to do is we're going to play around with some functions for a bit and find some antiderivatives. Then we're going to look at some rules for finding antiderivatives. So let's see. 3x squared. What's that the derivative of? Well, if you think about it, it's the derivative of x cubed, because derivative of x cubed is going to be 3x squared. Let's see, the rest of these, we should be able to get these by thinking about the derivative rules that we've learned and just kind of applying them in reverse. So let's see, 2x, what's that the derivative of? Well, we've already seen x squared. What about sine x? What is that the derivative of? Is it the derivative of cosine x? Well, if you take the derivative of cosine x, the derivative of cosine is negative sine. And what we're doing is we're trying to move backward. So the derivative of cosine is negative sine, but the derivative of negative sine would be negative cosine would be positive sine. So this is going to be negative cosine. All right, secant squared. What's that the derivative of? Tan. All right. X squared. Let's see, what is x squared the derivative of? Well, this one might be a little tricky because you have to kind of think backwards. If you think about this, let's see, we're taking the derivative of something and we're supposed to get x squared out of it. Well, this would have had to have been x cubed, but that's not quite right yet. Derivative of x cubed would be 3x squared. So this is going to be 1/3. So my answer here is 1/3 x cubed. Now notice one thing I should say. This says find an antiderivative. If I want to find the general antiderivative of all these, I could just put plus c on all of them. But since it just said find an antiderivative instead of the general one, I'm just putting down the simplest one, the one that has 0 for its constant. All right, I'm going to do these a little out of order. What is 5 the derivative of? Well, it's the derivative of 5x. What's cosine the derivative of? Cosine is the derivative of sine. Okay, what about this one? Well, actually, we've already done pretty much this. 2x is the derivative of x squared. And what is 4 the derivative of? Well, 4x. So on all of these, you can go back and take the derivative. Derivative of this is going to be 2x plus 4. So the antiderivative of 2x plus 4 is going to be x squared plus 4x. All right, what about this last one? Secant x, tan x. What is that the derivative of? Well, it's the derivative of secant. So its antiderivative is going to be secant x. All right. So in all of these, I know I went through them quickly. Some of them are probably fairly simple to you. Some of them might not make some of them might be a little tougher. But by thinking about the derivative rules backwards, we can come up with some antiderivatives. But what's nice is we have a bunch of rules for dealing with antiderivatives, and we'll look at those in the next video.